Calculating the pH and equivalence of a titration. Today we'll be discussing a weak acid strong base problem. As you can see here, our equation reads, a chemist titrates 170 milliliters of a 0.4434 m carbonic acid solution with 0.6382 m potassium hydroxide solution at 25 Celsius. Calculate the pH at equivalence. The pKa of carbonic acid is 3.60. Be sure to round your answer to 2 decimal places. Our first step is to write the equation. Why? A quirky way to remember this is how salty are the haters. Why do you ask? An acid-base reaction always produces a salt and a water. When we're at equivalence, at equivalence means that our moles of our carbonic acid will equal our moles of potassium hydroxide. So in this formula for this equation, this is what at equivalence looks like. So now, another quirky way to remember our step 2, which is to calculate the volume at equivalence, is 2 ways. One, always write your M1, your B1, and your M2 in the beginning. And also, I provided a quirky little song that you can sing to remember the gist or the formula for calculating the volume at equivalence. I don't think you're ready for this volume. I don't think you're ready for this volume. I don't think you're ready for this, cause we're calculating the volume at equivalence. Make your ones move side to side. Make your M2 touch the ground. I can't help but wonder why. Is my B2 too voluminous for you, babe? Now that embarrassment is over, let me break down the song for you. It says, basically to memorize the song would be in this verse where it says, because we're calculating the volume at equivalence, make your ones move side to side, make your M2 touch the ground. I can't help but wonder why. Is my B2 too voluminous for you, babe? So that means that when I say make your ones move side to side, I'm saying multiply your M1 times your V1, and then make your M2 touch the ground. Means you're going to put your V2 at the bottom, and then in the end you'll get your V2. So for this equation, our M1 was 0.4434. Our first volume was 170 milliliters, and at the bottom we had 0.6382 meters. That gave us a total of 118.1 milliliters. So when salts are in the presence of water, water does this thing called hydrolysis. Hydrolysis splits them apart into the ions that originally formed them, and this is what we would consider an ionic compound. As you can see, for our equation, hydrolysis produced a potassium and bicarbonate ion. So now ask yourself, who wears the pants in the relationship? This is another quirky way to remember to see who kind of controls the pH. Is it potassium hydroxide or is it bicarbonate ion? The bicarbonate ion is the one that controls the base, and you can kind of see it here as I have it highlighted. Remember, potassium does not control the pH because potassium comes from a strong base, potassium hydroxide. So it does not control the base. So our step 3 is going to be to calculate the moles of the bicarbonate ion. So here we're going to multiply our volume 1, as you can see here, which is 170 milliliters, times our M1 value, which is the 0.4434, divided by 1,000, and that's going to give you 0.0754 moles. So we did that we calculated the moles of bicarbonate ion using the volume and the concentration. However, in order to complete the actual concentration of the bicarbonate ion, we needed to divide the moles of the bicarbonate, which is what we got in our earlier equation, which is 0.0754, by the total volume. We got the total volume by combining our volume 1 value, which is 170, times the volume we got earlier that we spoke about during our little song and dance moment, which is 118.1 milliliters. That will give you 288.1 milliliters. Then we converted from milliliters to liters, which we got 0.2881 liters, and then we divided that, and it got 0.2617 as our answer. So our 0.2617 was our molarity. Now that we know our molarity of the bicarbonate ion that controls the pH, we are able to create a nice table. A good nice way to remember this is to say ice, ice, baby, and that you know it's your fourth step. So I have my ice table already set up, and I have my carbon and bicarbonate ion, and that's right here, and that's H2O. So I'm going to take my concentrations that we calculated, which is 0.75 minus X, and then here's going to give E. Now it's for step 6, which is simplify. Ask yourself, can you simplify? For our equation, we can simplify actually, because if you look, we can divide our X over the X. So this we can cross out. Then we would cross multiply, which would get 3.98 times 10 to the negative 11th power times our 0.0754. It's going to give us X to the second power. Then you'll see our final answer is 3.00 times 10 to the negative 12th power. And now it's going to be time to calculate our POH. We're going to negative log our answer that we got from cross multiplying, which was 3.0 times 10 to the negative 12th power, and get 11.52. 11.52. What is the pH? Well, we're still not done because we have to subtract 14.0 minus our 11.52 that we just got to get 2.48. So our pH for this equation would be 2.48.